Solar geoengineering is the idea that humans might deliberately alter the planet's reflectivity by engineered means. This could significantly reduce some of the risks of climate change. Perhaps the most important thing to know off the top is that at best it's a partial supplement to cutting emissions, but not a substitute for it. In the end, we must bring emissions to zero if we want a stable climate. But there's evidence that solar geoengineering could significantly reduce risks, like the risks of extreme storms, tropical cyclones, or sea level rise, or peak temperatures. There are a number of methods that have been proposed, but in generally they've been inadequately researched. Perhaps the best known methods are the idea that we might add aerosols to the stratosphere, where they would mix pretty evenly and reflect away some sunlight. A related idea is that we might try and seed high-altitude cirrus clouds to reduce the cloud density in a way that makes the Earth less infrared opaque, in some way might be a better compensation for the heat-trapping effects of carbon dioxide. And the third major idea is the possibility of adding seed particles to certain kinds of marine boundary layer clouds that could make them whiter. All of these ideas have real potential to reduce climate risks, and yet for all of them, research has been profoundly inadequate. On the one hand, this idea is not new. Indeed, the idea appeared in the 1965 Restoring the Quality of Our Environment report that went to President Johnson, which was the first major report to get to a US president on climate change. And the idea was there in, they say, the National Academy reports of 1977, and the one in the early 80s, and the one in the 90s. So the idea is old. But for a long, long time, there was a deep taboo against research. And even now, there's no organized US federal research of any kind. However, in the last few years, there's been a growing interest. There are now some hundreds of papers that at least deal with the topic, and there are now research efforts that are organized in China and in several different ones in Europe, and there's a growing body of interest. Perhaps most importantly, there's now real effort to think seriously about governance challenges, which are probably the biggest single challenge with this technology. And the most important example of that is that a gentleman called János Pastor, who was formerly the chief advisor to the UN Secretary General for Climate, is now running an effort to look at global governance of solar geoengineering. Most research to date has simply adjusted the solar constant in climate models, or used a very simple process to adjust the stratospheric aerosol concentration in such models. That research has showed us something important, that solar geoengineering, in some way that I think is quite surprising, can actually do an impressively good job in compensating on a regional basis for changes not just in temperature, but also in precipitation. So that's the good news, and it's the reason to take this seriously. But the depth of ignorance is really high. There's been very little effort to carry that on into a serious look at climate impacts, to look in a deliberate way at the specific climate impacts we care about and to understand the extent to which they could or could not be reduced by solar geoengineering. There's also been very little effort to think seriously about how these things would actually be implemented and what the side effects would be. For example, what materials might actually put in the stratosphere, how you would monitor them, what the various side effects and risks would be. Almost no serious research has been done on these topics. The basic argument for research is that it can reduce ignorance. Our children, or their children, will make decisions involving solar geoengineering whether or not we have a research program. We can't uninvent the technology. It's on the table. My point of view is that having a serious research program, one that is international, open access, a research program that spends a lot of its time looking for the ways that could go wrong, with a good kind of blue team, red team tension, where a small amount of research is devoted to figuring out how to make it work better, and there's lots of independent critical thinking about how it's going to fail. A research program like that does not commit us to implementation, because nobody sensible now believes implementation makes sense. But a research program like that could tell us an enormous amount, relatively quickly, about the risks and efficacy of this technology, and that allows the next generation to make better decisions. That's the long-term argument for research. But now let's turn to the present day. Establishing a US geoengineering research program makes sense in general, but under the current administration, it's at best questionable. This administration appears to be committed to making deep cuts both in climate science and in the action to cut emissions. And if, under that circumstance, which is not given but seems likely, it also initiated a serious new effort on climate geoengineering, I believe what would happen would be a strong backlash, where environmental forces that are sensibly trying to push for emissions reduction would argue that such a program was a deliberate way to avoid action on emissions reductions, which it shouldn't be, but would appear to be. And it would make that program sort of fundamentally unsustainable. Because in the long run, what we need is a global or highly international program, and one that can be sustained and gets broad support over decades. And so I think the question of whether or not we ought to set up a US research program now is a very hard call.